To finish off with this idea of sketching, let's look at our trig functions. So we'll start with the sine curve. I'll mark off the amplitude there, 1, -1, and the boundary values. So I'm doing it in radians, so every pi on 2. We know the sine curve starts at the origin, and then it goes up to the amplitude, and then back down to the axis, and up and down, and up and down. And of course we draw a nice smooth curve. So there's y equals sine x. Now what do we know about it? Well, we can see the domain is all real x. The range, -1 to 1. Well, that's if it's just y equals sine x. Well, now if we look at this idea of translating and dilating and reflecting, we can generalize this. So if I have y equals some number, a, times the sine, and then the function there is bx minus c. The period, so how often it repeats, will always turn out to be 2 pi divided by b, so the coefficient of x. Now that's useful to know when I'm sketching my curve, because what I'm going to do is I'm going to mark up my divisions based on that. Amplitude, the other piece of information, well, that's the coefficient of the trig function itself. So the divisions I'm going to mark off will be whatever the period is divided by 4, because it's each of the boundary values. And when we go around the circle, there are 4 quadrants. Phase. What's phase? Phase basically is the shift of the curve. But remember, when we're talking about a horizontal shift, it needs to be grouped with the x. Now, bx minus c is not grouped with the x. If I was to factorize that so it was grouped with the x, I'd actually have c divided by b. So the shift is going to be c divided by b. It's an odd function, so we know it has that rotational symmetry, but also means, if I ever need to, I know that the sine of negative x must be the same as negative sine x. Satisfies the condition for an odd function. So let's go crazy. Y equals 5 times the sine of 9x minus pi on 2. If I had to draw this, the period 2 pi divided by the coefficient of x. So now the period's going to be 2 pi on 9. The amplitude, coefficient of the trig function itself, 5. I'm going to mark off my divisions every pi on 18. So the period divided by 4. We also have a shift, but the shift will be pi on 18 to the right. So it's pi on 2 divided by 9. Let's draw up our axes. And in fact, I could draw the same set of axes for every graph. I just change the labels. So the amplitude now is 5 and -5, and my divisions now are every pi on 18. But other than that, it's still the same sine curve, except for the shift. So normally I would start at the origin, but I'm shifting this curve pi on 18 units to the right. So I'll start at pi on 18. But I still know the way the pattern goes. I will then go up to the amplitude, back down, and then up and down, and there's my sine curve. All right, let's look at cosine. I won't redraw the basic one, but to generalize this one. So y equals a, the cosine bx minus c. Period is still going to be 2 pi on b. Amplitude is still a. Of course it's the same, because the sine curve and the cosine curve are the same curve. It's just that one's shifted. So I'm still going to mark off my divisions, period divided by 4. The phase is still c over b. It's an even function, however. So in this case, cos of minus x will equal cos of x. Let's go real crazy with this one. Y equals -4, the cosine of x on 8 plus pi. And what the heck, let's add another 2 in as well. So the period, 2 pi divided by 1/8 is 16 pi. The amplitude is 4. I will mark off my divisions then every 4 pi, period divided by 4. Shift, what have we done? Well, this one's going to be 8 pi to the left and then 2 up, but also we've got that negative out the front, so it's upside down as well. Marking the axes. Because I've shifted it up 2, you notice I've drawn a dotted line there at y equals 2. It's going to be the axis of the curve that I'm going to draw. So I kind of need that line so I know where to plot those points. The amplitude we said was 4. So therefore this will go up to 6, down to -2. Mark off the divisions of the x-axis. I said I was going to do that every 4 pi. Okay, cosine function. Well, the cosine function would normally start up at the amplitude. So this one will start at 6, except it's also upside down. So I'm going to start down at -2. But we've also got a shift to the left. So I'm actually starting at -8 pi -2. Okay, what does a cosine curve then do? Next division then would be at the axis. Then I would continue up and then down and up and down. And we have our rather strange cosine curve. Well, it wouldn't be complete unless we did tan as well. So tan, y equals a tan bx minus c. Period, this time is pi on b. Sine and cosine 2 pi on b. Tan's pi on b. Because the basic tan curve has a period of pi. Divisions, therefore, will only be period divided by 2. Again, if you look at the basic tan curve, it repeats every pi, so I only need 2 quadrants. Phase is still C on B, that's not going to change. I haven't bothered with amplitude because a tan curve doesn't have an amplitude. It just goes up to infinity and down to minus infinity. It's an odd function, so I could use the fact that tan negative x is negative tan of x. Y equals E tan pi x minus 2 pi. Period is just 1 for this one. So pi divided by the coefficient of x. I will mark off my divisions then every half. It's been shifted 2 to the right. Okay, let's mark in our information. So mark off those divisions. How does a tan curve go? Well, it normally starts at the origin, but I've shifted 2 to the right, so I'm going to start at 2. The pattern for a tan curve, x-intercept, asymptote. X-intercept, asymptote. So let's do that. There's the asymptote. Now go back the other way. And now we draw in our tan curve. Well, that's in one section. Let's put it in all the sections. The E out the front of this one kind of is irrelevant because I haven't actually marked a scale on my y-axis, but I could have put any number there. 3J.